Settle into a comfortable spot. Let your shoulders soften and feel the day drift to the edges like evening light on a quiet porch. The room is dim, the chair steady, your breath moving in and out like a small tide. You are safe here. Tonight we'll wander gently through a tender question. If nothing exists outside the universe, what is it expanding into? We'll hold that thought like a smooth stone in the palm, turning it slowly while the noise of the world fades. No rush, no pressure, only calm, curiosity, and the soft rhythm of rest. We'll speak of space as a fabric that stretches from within, of distances growing without needing an outside, and we'll let each idea arrive like a wave that knows where to go. If this quiet company helps you unwind, a light tap on like and subscribe helps other night travelers find this harbor too. For now, close your eyes. Let's begin. The universe is growing, not racing like a car on a road, but stretching the way a quiet breath opens your chest. With every heartbeat, the space between faraway galaxies lengthens. What twists the mind is this: it doesn't grow into anything. There's no hallway outside, no blank container waiting to be filled. Space makes room from within, the way night gathers without needing walls. To hold this gently, picture a balloon, but change the rules. In your living room, a real balloon pushes against the air, expanding into the room. That's how things behave on Earth. Our bodies learn that pattern early. Plants grow into air, towns spread into fields, ice reaches across a lake. Expansion always has somewhere else to go. The cosmos smiles at that habit and offers another picture. Imagine a balloon where only the skin matters, and you live on that skin. As it inflates, every point drifts from every other point. Yet, there is no outside place the surface expands into for those who live on it. The surface itself is all there is. Now trade that thin surface for the full, three-dimensional space you live in. There is no cosmic living room, no outer boundary, just more space, made by space. If the balloon still feels tricky, try a sheet of paper. You want to draw a circle larger than the page allows. On Earth, you'd reach for a bigger page. In the universe, the page itself quietly grows, and your circle fits without a margin. That sounds impossible only because our daily lives are built on edges and containers. Out here, the container is the thing being made. Astronomers learned this not by guessing, but by listening to galaxies. When Edwin Hubble and others measured their light, they found a simple rhythm. The farther a galaxy is, the faster it seems to recede. It's tempting to imagine a grand explosion with us at the center, but there is no special seat, no middle chair. The galaxies aren't racing through space like birds through air. The space between them is widening. Think of tiny dots on a balloon's skin, drifting apart as the rubber stretches. Each dot sees all the others move away. None is privileged. None sits at the true center. Light tells the most tender version of this story. A beam leaves a distant galaxy carrying a specific color, a wavelength like a note on a string. During its long journey, the floor beneath it, the fabric of space itself, lengthens. Each wave is tugged a little longer, like a traveler walking across a moving walkway that slowly stretches underfoot. By the time the light reaches our mirrors, a blue note has slid into red into a deeper hush. This gentle pulling is called cosmological redshift. It's not the same as the siren of an ambulance moving away. It's the path itself growing under the sound. Some of the oldest light we can observe has been stretched many times over radiation that began as fierce ultraviolet, arriving as faint, warm infrared. What started as a bright shout becomes a soft whisper, yet the message is clear. Space grows on its own schedule, independent of the things inside it. And this widening does not choose special places. It happens everywhere, even here, very faintly, in the quiet between your eyes and this screen. You don't feel it because forces in matter, tiny electric bonds between atoms. The grip of gravity in families of stars holds small and local things together. On the grander stage, where galaxies drift with only gravity's broad guidance, expansion has room to show itself. The image that helps many people is a loaf of raisin bread rising. The raisins don't swim through the dough. The dough swells and carries them apart. You and I, and every galaxy we can name, are part of the dough. Asking what the dough expands into is like asking what's north of the North Pole. The question sounds natural, but the map ends because the map is complete. Let your shoulders ease while this lands. It's all right that the mind resists. It was trained on bowls and boxes. The universe offers a softer lesson. There is no outer bowl. Growth is not a thing moving into emptiness. Growth is the fabric making more fabric. If you wonder how far our listening can reach, the answer has its own kind of lullaby. We see only as far as light has had time to arrive. Beyond that lies not a wall, but a horizon woven from time like fog at sea that thins as morning comes. Every year that passes, more of the ocean of space comes into view, not because we're sailing outward, but because more light has finally reached our shore. Breathe in, slow and easy. Imagine space as a vast, dark quilt, threads relaxing by a hair's breadth. With each breath, the cosmos takes. Breathe out and feel how this easing makes room for stars to cool, for planets to find calm paths, for seas to remember the moon. Somewhere, a galaxy's first stars flare and fade, writing the earliest lines of a song whose later verses include trees and rivers and the small kindness of a hand at rest. The stretching of space does not rush you, it invites you. Let the picture be simple. No outside, no edge, only a patient widening that carries distant lanterns farther apart while leaving you nestled exactly where you are. And as you rest with that, the light from far away keeps arriving, redder, softer, older, like footsteps thinning on a long hallway. The story they bring is steady and kind. The stage expands from within. The actors drift because the stage grows. And the only boundary you meet tonight is the gentle horizon of time, waiting like a shoreline for tomorrow's tide of light. Step into the night, the way you step into a warm bath, slowly, shoulders loose, breath unhurried. The sky above feels like everything at once, yet what reaches your eyes is only a small circle of knowing, a gentle horizon drawn by time. You live inside an invisible sphere, a bubble of sight about 46 billion light-years in radius. Beyond that soft edge, more universe continues, more galaxies, more stars, perhaps whole tapestries of worlds, but their light hasn't had time to arrive. Not because there are walls, but because even light, swift as it is, needs years to cross the dark. Light carries memories. The sun you see is 8 minutes old. The nearest star system, Alpha Centauri, waves to you from 4 years ago. Andromeda sends a postcard from 2.5 million years back, when our ancestors traced constellations with different names. The farther you look, the farther back you listen. The universe has been singing for about 13.8 billion years. No note older than that can have reached our shore. Yet space has been stretching all along, so the places that sent the oldest notes have drifted outward while their messages were en route. What began much closer now sits roughly 46 billion light-years away. Your horizon is not a fence, it's the farthest echo you can currently hear. Think of standing in a quiet fog. You can see a circle of field around you, and you trust the meadow goes on, even when the mist keeps its secrets. The observable universe is that circle. The larger universe is the meadow. If the meadow has no end, if space is truly infinite, then your bright little bubble holds essentially none of what exists. A tender speck in an endless hush. Strange as that sounds, it doesn't scold, it soothes. You are held inside a horizon that grows with every moment. A lantern whose light reaches a little farther each breath you take. From every direction, the oldest light we can see is arriving, swift and steady, about 670 million miles per hour, an afterglow from when the cosmos was a newborn. Long before Earth cooled, long before the sun learned its steady flame, the universe was a hot sea of plasma, where light could not travel far. Photons bumped into charged particles the way raindrops vanish into steam. Then the fabric cooled enough for protons and electrons to settle into the first hydrogen atoms. The fog thinned. Space turned transparent. The first free light slipped its cradle and set out. We meet that light today as the cosmic microwave background, a faint, ancient warmth that fills every inch of space. Old televisions once caught a whisper of it in their static, the universe humming in the snow. That glow is our farthest visible shoreline. Before about 380,000 years after the beginning, the cosmos was opaque, like trying to see through the sun's surface. No instrument looks past that, because there is no past that to look through with light. It's a soft wall made of youth, the moment sight became possible. Each second that passes, slightly older light arrives 13.8 billion years, plus a heartbeat, and your horizon widens by 1 light second. The map grows, even as the landmarks drift outward on the slow tide of expansion. We see where distant galaxies were when they sent their messages, not where they now rest. It's like watching someone walk away in a film, while the screen itself gently expands. When we listen closely to that ancient glow, it is astonishingly smooth, more polished than a mirror with only tiny ripples, temperature differences of a few millionths of a degree. Those small ripples are the seeds of everything that followed. Rivers and rocks, clouds and cities, sleeping cats, and the taste of tea. On the largest scales, the universe appears uniform, homogeneous, the way a well-mixed batter tastes the same from spoon to spoon. If one observable bubble like ours holds roughly the same kind of galaxies in roughly the same proportions, the next bubble over likely does too, and the next, as far as the fog allows. The idea stretches farther than comfort and then becomes calm again. If space truly has no end and stays broadly the same from place to place, then arrangements of matter must repeat. That's not mysticism, it's arithmetic. With infinite room and only so many ways to arrange a finite number of particles within any given volume, patterns recur, the way a shuffled deck, given endless shuffles, will deal the same order again. Somewhere past any hope of contact, there could be scenes that rhyme with this one. Another porch of night, another steady chair, another you pausing between breaths. Not copies to worry over, just distant verses in a long, repeating song. Let the mind drift the way starlight drifts patient, unhurried, content to take the long way home. Some ideas arrive, with numbers so large they dissolve into music. One estimate for the distance to a region of space arranged exactly like ours, another you. Another quiet room uses a stack of exponents so tall that writing the number out would require more space than our observable universe holds. It sounds outrageous, yet if space truly has no end, very far is still only a kind of near. Somewhere, a distant version of this moment may be unfolding like a rhyme you'll never quite hear. That picture assumes the parts we can't see resemble the part we can. Perhaps they do, perhaps they don't. Our own neighborhood may be slightly undercrowded, a gentle cosmic cul-de-sac where the galaxy traffic thins. Far beyond our horizon, there could be busier districts, clusters piled high with stars and black holes, or wide, quiet basins with hardly a spark. Some models of the universe's first blink, the rapid ballooning we call inflation, suggest that other pockets might exist with different settings entirely. Altered constants, unfamiliar particles, physics that would turn our textbooks into poetry. These are working theories, soft sketches pinned to the board until the data hums the same tune. Let the breath come and go while we loosen a different knot. How can something infinite get bigger? Mathematics smiles and says it doesn't. Infinity is already all the rooms. What changes in an expanding universe isn't the amount of infinity, it's the scale. Picture an endless sheet of graph paper with 1-inch squares. Stretch it so each square is 2 inches across. The paper remains endless, only the spacing grows. 2 marks that were 1 square apart are now 2 squares apart, even though the sheet never needed an edge to pull from. That is what expansion means. The yardstick itself lengthens. Follow that to the beginning, and the beginning changes shape. The Big Bang wasn't a firecracker at a point throwing sparks into emptiness. It was the everywhere fabric, warming, then cooling, all at once. No center to point to, no rim to find, just every place beginning together. From any galaxy, the view looks the same on the largest scales, which is why no address is privileged. Expansion has no throne room. A new worry sometimes tiptoes in. If the universe could be endless in both matter and space, why aren't we crushed beneath infinite density? Because density is a ratio, not a sum stuff per volume. Both can be vast beyond telling, while their quotient stays gentle. On average, spread across the great dark, the material of the universe thins to only a few hydrogen atoms worth in each cubic meter, with most of the cosmic budget carried as invisible forms, dark matter shaping, dark energy easing everything wider. Here the paradox turns personal, and then soft again. If space is endless and broadly uniform, arrangements repeat, not in a mystical way, but in the simple arithmetic of possibilities. Given enough room, every permissible story finds a stage, and many stages host the same play with small variations in the lighting. Somewhere, a river bends left, where yours bends right. Somewhere, a version of you closed their eyes 1 breath earlier. None of these scenes can visit you, and you do not owe them worry. They are distant verses in a song whose chorus you already have. And if the universe is not boundless after all, then an edge demands its own lullaby. What could outside mean for the fabric that defines distance itself? How would a traveler meet a boundary that is not in anything? These questions have a way of folding back into the same calm. Current measurements of the ancient afterglow show a geometry so nearly flat that any curvature hides beyond our detection. The simplest reading is that space extends without end, or so far that, for all practical dreaming, it might as well. So what coaxes the fabric to keep easing wider? Not a factory on a hill, not a pump behind the stars, but the quiet energy of the vacuum itself. Empty isn't empty. Even in the cleanest darkness, quantum fields fizz with brief, virtual pairs, tiny loans repaid almost instantly. That restless baseline energy behaves strangely under gravity. Instead of tugging things together, it presses space apart. A gentle, persistent push. The more room there is, the more of this vacuum energy there can be. The more of it there is, the more the fabric relaxes. A self-feeding hush, not a stampede. You don't have to grip the equations tonight. Let the images do the lifting. An endless quilt whose stitching loosens a hair with each cosmic breath. A graph paper sky whose squares grow wider while the sheet remains without edges. A neighborhood of galaxies in a quiet cul-de-sac, and far beyond the fog, other districts busy or bare. A beginning that happened everywhere, so every place can point to itself and say, gently, here is where the story started for me. Set another thought on a lantern boat and watch it glide. Whether the meadow is endless or vast beyond our footsteps, whether distant pockets hum with different rules or rhyme with our own, the night remains kind to the small scale of a human breath. Expansion does not hurry you. Infinity does not demand that you understand it before sleep. The fabric will go on making more fabric. The light will go on arriving, older and softer, and you will go on being right where you are, held in a universe whose wideness is not a threat, but a spaciousness you can rest inside. Let the thoughts slow to the pace of your breath, while the fabric of space does its quiet work. When there is more room, there is more vacuum energy to gently push that room wider, a feedback so strong that in the first flicker of time it ran away with itself. This was inflation. Nothing outran light. Instead, the stage lengthened faster than any beam could cross it, like stepping onto a treadmill that accelerates beyond your best sprint. In less than a trillionth of a trillionth of a trillionth of a second, a region smaller than a proton swelled to something like a basketball. It sounds unreal, yet quantum rules allow brief loans of energy. The uncertainty principle so long as time settles the account. During inflation, space borrowed big and repaid by expanding, and it overshot. Our entire observable sky is just a pin dot on that vastly larger cloth. Hold a picture, a balloon blown up to Earth's size, and your gaze resting on a speck no bigger than a pinhead. That speck is our observable universe compared with the region inflation unrolled. The wild growth has calmed, but a softer easing continues. Today it goes by another name: dark energy. About 68% of everything. A uniform pressure with repulsive gravity that lets distances lengthen a little faster as time passes. It feels as if space is minting new energy and breaking an old rule. The ledger balances, though, because gravity keeps negative books. As matter spreads out, gravitational binding energy becomes more negative, offsetting the positive energy of the vacuum. The totals cancel. The fabric keeps relaxing, and it will keep at it for an unimaginably long time perhaps. For our purposes, effectively forever. All this would be only a bedtime story without a nightlight left on for us. In 1964, two radio astronomers tuned their antenna and met a hiss that would not leave. They pointed it here and there, cleaned away bird droppings, recalibrated with patient care. The whisper stayed. It was the afterglow of the beginning, the cosmic microwave background. When this light first slipped free, the universe glowed around 3000 Kelvin, a warm orange-white. As space stretched, its color slid. Brilliant visible light to infrared, to microwave, even brushing radio. Until today, it arrives as a faint bath, just 2.7 degrees above absolute zero. The glow is astonishingly smooth, uniform to a few parts in 100,000, exactly the polish a burst of inflation would leave behind. Listen closer, and the smoothness has freckles. Those tiny temperature ripples are the fingerprints of quantum jitters, stretched from subatomic scales to cosmic size. The first seeds of structure. From them grew the swirls of galaxies, the cradles of stars, the quiet shores where oceans learned blue. Satellites like Cobe and Planck mapped these ripples with exquisite care, and from their pattern, we can read the room. Space is flat, within measurement error. Ordinary matter, the kind that makes stars, seas, and you adds up to only about 5% of the whole. The tempo of expansion and the age of the cosmos fall out of the music of that light with remarkable precision. All of this from a whisper in the static. Another image to cradle. Everything you can see, the rivering arms of the Milky Way. The deepest clusters, the faintest smudges at the rim of sight, once fit inside a volume no bigger than a beach ball. Not matter stuffed into a tiny box, but space itself, that compact. The ball wasn't inside anything. The ball was everything. Then the fabric began its patient loosening, and the room we live in opened. What, then, drives the dimmer switch now? At the end of the last century, 2 teams watched distant type Ia supernovas, those steady cosmic candles, hoping to measure how much the expansion was slowing under gravity's pull. Everyone expected a gentle breaking. Instead, the light returned a softer, stranger answer. The universe is speeding up. That quiet shock, later honored at the highest level, gave a name to the hand on the switch. Dark energy, the same gentle pressure that now persuades distances to grow. Let the numbers soften into breath. Inflation's wild sprint in the first instant. A universe that still eases wider under a uniform hush. A baby picture of the cosmos glowing at to 3000 K. Cooled to 2.7 K by the long stretch of space. Freckles in that glow that became galaxies. A flat geometry and a small luminous slice of ordinary matter, about 5% holding our stars and stories. The rest is the dark scaffolding and the quiet push. None of it asks you to hurry. The fabric will go on making room. The light will keep arriving, older and softer. And you are exactly where you need to be to hear it. Somewhere far away, a certain kind of star ends in a bright, predictable farewell. Astronomers call these farewells type Ia supernovae. They are wonderfully consistent cosmic lighthouses that flash with almost the same true brightness wherever they occur. Because their wattage is known, their apparent dimness tells us exactly how far they are. It's the oldest trick in navigation. If you know how bright a beacon should be, you can measure your distance by how pale it looks. With that simple idea in hand, 2 teams set out in 1998 to check how much the universe's expansion had slowed under gravity's pull. The expectation was gentle braking. The data said otherwise. The faraway supernovae were fainter than they should have been, as if their host galaxies had drifted farther during the light's journey than any steady expansion could explain. The only way to square brightness with distance was to admit a stranger. Expansion is speeding up. Space isn't just stretching, it's learning to stretch faster. The name we give to the pusher behind this acceleration is dark energy. The name is modest, a placeholder that says we see the effect, not the cause. Dark energy doesn't clump into stars or swirl into clouds. It doesn't thin out as space grows. Its density stays essentially constant, like a perfume evenly mixed into air that keeps refilling the room as the walls quietly slide apart. That one odd habit staying constant while volume increases means its total influence grows with time. In the crowded youth of the cosmos, matter and light ran the show. As the universe expanded and matter spread thinner, the even pressure of dark energy emerged from the background and took the lead. Around 5 billion years ago, roughly when our sun and its planets were gathering themselves, dark energy became the dominant actor. We live inside the age of acceleration, where each day adds a hair more speed to the universal exhale. Numbers can be calming when they're not rushed. In the grand energy ledger of the cosmos, dark energy accounts for about 68% of everything. Ordinary matter, the stuff of stars and seas and you, fills only about 5%. The rest is dark matter, the unseen scaffolding that holds galaxies in their graceful spins. By simple ratio, dark energy outweighs normal matter more than 13-to-1, and it even overrules dark matter at the largest scales. Yet it gives us no shimmer to study, no obvious handle to hold. You can think of it as the fabric's own preference for easing outward, an internal pressure that turns distance into something a little roomier, moment by moment. Over human lifetimes, acceleration is too subtle to feel. Over the long weather of cosmic time, it changes the map. In the far future, distant galaxy families will recede so quickly that their light can never bridge the growing gap. Not because anyone breaks the speed of light, but because the road itself lengthens faster than a beam can cross it. The night sky of that far tomorrow will grow sparse, like a town whose neighbors have moved beyond the horizon. This is not a danger to store in the heart. It is a reminder that the stories we read in the stars are always a chapter behind the pace of the universe. If we ask what dark energy is, the first answer on the table is vacuum energy, the hum of quantum fields that never quite settled to perfect silence. Even the emptiest space bubbles with virtual pairs that flicker in and out of being in time shorter than any clock can crisply name. Quantum field theory, when asked to total that background energy, hands back an absurd figure about 120 times larger than what the cosmos seems to display. It's been called the worst prediction in physics, a comic mismatch that tells us something in our reasoning needs stitching. Perhaps there's a delicate cancellation we don't yet understand. Perhaps dark energy isn't a constant at all, but a new field that changes slowly, something like an ultralight fluid permeating space. Perhaps gravity itself bends its own rules on the largest scales. For now, humility is the wise blanket. We model what we can see. We let names stay soft, and we keep listening. Before dark energy took the stage, another expansion danced across the earliest instant, a sprint so swift that it remade the stage itself. This is inflation. The burst that happened in a sliver of a second after the beginning, a time so brief that light could not have crossed the width of a proton. In that heartbeat of birth, the distances between points doubled and doubled again in a fever of growth. At least 26 times larger in about 10-35 seconds. Numbers that sound like myth until you hold the right picture. Nothing was racing through space. Space was the thing that raced. If you prefer a gentler image, try a treadmill that accelerates under your feet. No matter how fast you run, the belt speeds up more, and the far end keeps sliding away. During inflation, the separation between any 2 points increased so quickly that signals of light couldn't keep up. Regions that shared information were torn out of contact forever, not by force, but by geometry. The likely engine of this sprint was a field we call the inflaton, a hypothetical cousin to other quantum fields, trapped temporarily in a false vacuum, a high-energy state that mimicked a powerful, uniform pressure. While the field was stuck, space grew exponentially. When it relaxed, That stored energy reheated the newborn universe, seeding particles and light and the chemistry of the future. Inflation carries practical comforts. It explains why the oldest light, the cosmic microwave background, is so smooth across the sky. Before inflation ran away with the stage, nearby regions could trade heat and even out. Then the ballooning stretch froze that smoothness across vast distances. Inflation also irons the wrinkles of space. Any early curvature would be stretched so much that, from our small vantage, the geometry looks flat, like standing on an enormous sphere and seeing only a level field in every direction. Its deepest gift is both tiny and grand. Inflation took quantum jitters and magnified them into the first seeds of structure. Minute fluctuations of energy density, random, restless, unavoidable, were stretched from the subatomic to the cosmic. Where the field was a whisper denser, gravity had a little more to work with. Matter flowed toward those places. Galaxies formed, stars lit, planets cooled. Trace the history of any stone, any leaf, any heartbeat, and you arrive at those first murmurs. You are, in a quiet and literal way, the descendant of quantum foam. When a mechanism is natural, the mind asks if it could happen again. Certain models say yes. Inflation may be eternal in patches, with new bubbles igniting here and there as quantum chance trips the right conditions. A bubble would expand at light speed, carrying different physics inside it, new settings for nature's dials. That sounds alarming until you lay it next to scale and probability. The cosmos is vast beyond telling, and the odds of such a bubble appearing in our tiny address during the human page of time are so slight that they dissolve into the evening air. You needn't watch the horizon for it. The kettle can keep humming. The cat can keep sleeping. From that possibility flows another picture, a multiverse of bubbles, each a universe with its own history, each blossoming from the same inflationary tree. In some bubbles, gravity might be stronger, crushing stars into black holes before they can host planets. In others, it might be too weak to gather matter at all. Most would be sterile. A few could be generous. Ours, by every sign, is one of the generous ones, imperfect, yes, but balanced just enough for long-lived stars and liquid water and the slow, delicate experiment of life. Return, just for a moment, to the supernova lighthouses that set this part of the story in motion. Their flicker reaches us from billions of years away, carrying a message that the expansion is not coasting but accelerating. The microwave background, cooled to 2.7 degrees above absolute zero, bathes the sky with a near-perfect evenness, its tiny speckles aligning with inflation's predictions. The matter we can touch and see accounts for only a sliver of the whole, while dark matter shapes halos and dark energy lifts the metric itself. Each piece supports the others like beams in a quiet house. Remove one, and the roofline stops making sense. It helps to keep three gentle metaphors near. For the acceleration, a quilt whose stitching loosens by an imperceptible hair with each breath of the cosmos. For inflation, a treadmill that ran far too fast for even light to keep up, then slowed to a stroll. For dark energy, a perfume that remains equally strong no matter how large the room grows, making the room larger simply by being there. If you let your jaw unclench, you can hear how these aren't threats, but lullabies. The universe is not rushing you. It is writing a patient sentence, comma by comma, across the dark. Somewhere, a type Ia supernova is adding a punctuation mark to that sentence. A bright, brief comma that tells us exactly how far the story has stretched. Somewhere else, the oldest light continues to arrive, a soft echo from a time when the universe glowed like warm metal. The numbers 10, -35 seconds, 10, 26 inches size, 68% of the budget. A mismatch of 10, 120 can sit on the shelf and hum. You don't need to carry them to bed. In the very distant tomorrow, when acceleration has thinned the sky, a patient observer might see only the nearest island of stars. Yet the truth carried in tonight's light won't be lost. The cosmos grew from a smooth, hot beginning. Tiny quantum freckles became galaxies, and a quiet, uniform pressure now eases the spaces between those galaxies wider and wider. Your part in this story is small and complete, a breath that comes and goes, a mind that can hold an image without gripping it, a body settling into the chair as the room cools. Let the last thought drift like a lantern boat on a still lake. Dark energy keeps its even push. Inflation's echo remains printed on the sky. The supernova candles continue to blink across deep time, confirming that the exhale is quickening. None of this asks you to hurry. None of it needs your vigilance. The universe will expand, whether you count it or not. Close the count book. Feel how the fabric under everything is softening a fraction, making room for the next breath and the next. The story can carry on while you rest. Picture a vast orchard of universes, most of them barren fields where nothing ever ripens. In some, the electromagnetic force never switches on. No chemistry, no atoms keeping company, only a quiet that never learns to speak. In others, inflation never ends. Space keeps doubling so quickly it never cools enough for atoms to settle. Sterile bubbles by the uncountable, a wide desert of almosts. And yet, an endless desert still holds oases without limit. If the multiverse is truly infinite, improbabilities lose their sting. However unlikely our particular blend of forces and constants may be, endless bubbles offer endless chances for the recipe to land just so, for water to stay liquid, for stars to last, for questions to learn how to ask themselves. Seen that way, our presence doesn't make us special, it makes us possible. We live in a bubble that allows lookers precisely because lookers can only arise in such bubbles. This is the anthropic principle set gently. We notice a universe tuned for life because noticing requires life. Not a stage designed for us, but a stage that sometimes permits an audience. The fine tuning that feels like a wink can be read as a filter. Countless curtains rise on empty theaters. Now and then the seats are filled, and a hand lifts, curious. There's a tug on the heart in that idea. If there are infinitely many bubbles, and if physics allows every permitted scene to play somewhere, what becomes of uniqueness? Does another version of you read these words one breath sooner, one breath later, one breath never? In a story where all endings are explored, do choices still matter? The mind can knot itself here. In the dark's gentler logic, meaning isn't erased by repetition, it is local. A song sung in 1,000 valleys is still sung once where you are. Your decision matters because you make it in this room, with this breath, on this night. Distant echoes neither consult you nor bind you. They are verses in books you will never open. The sharper edge of the debate is about testability. Bubbles beyond our horizon cannot send light or gravity our way. By design, they don't share a sky with ours. If their signals can never reach us, how could we check they exist? Some argue that untestable claims belong to philosophy rather than physics. Others point back to the mathematics of inflation. the same equations that neatly explain the smoothness, flatness, and seed patterns in our cosmic microwave background, because those equations whisper that inflation doesn't politely stop everywhere at once. It ends in patches, while elsewhere it keeps going. That elsewhere blooms into new bubbles. If we trust inflation to describe our own first instant, the garden it grows comes along for the walk. Not a proof, but a path that stays consistent where we can step. Evidence remains indirect and modest, which is how honest evidence often behaves. The oldest light, the microwave afterglow cooled to 2.7 degrees above absolute zero, carries subtle fingerprints that align with inflation's predictions. A sky, polished, almost smooth, freckled just enough for galaxies to form, and geometry so nearly flat that any curve hides beyond our measuring stick. These matches fortify the early chapter story and, by extension, lend quiet plausibility to the multiverse that rides with it. The hum says, the model holds water where we can drink. The mind, having wandered far, can wander farther. What if the canvas we call space has more directions than we can point to? String theory, an ambitious attempt to gather all forces under one roof, asks for 9 spatial dimensions in total, with 6 curled so tightly that even particles don't notice the turns. Picture yourself as a tiny traveler on a garden hose. You can walk forward and back and believe the world is a line. But the hose also wraps around. It has thickness. There are loops. Your feet are too large to explore. In that way, we move through 3 broad directions, while 6 smaller ones hide in the weave, present but out of step with our senses. If those hidden dimensions exist, they complicate and clarify at once. Our familiar 3-dimensional space could be a shimmering sheet, a brain floating in a higher dimensional bulk. Everything we can touch and measure, except gravity, may be confined to that sheet, like ink drawn only to the surface. Gravity, uniquely shy, can leak into the extra corridors, which may be why it feels so weak compared to the other forces. Most of its tug spreads where we cannot go. In this picture, the expansion we observe is our brain stretching inside the larger room, the way a soap film widens while the air around it goes about its own business. The question, what does the universe expand into, receives a soft, speculative answer, into dimensions you cannot point toward. Step 1, lay a stranger, and other brains may drift parallel to ours in those hidden directions, so close along a forbidden axis that the distance might be less than the thickness of paper, yet unreachable because we lack the step required. Another universe might lie there, quiet and complete. Another you, perhaps, tracing the same paragraph. In some models, brains occasionally collide. Their meeting releases energy that looks to us like a big bang, a restart, a warming, a new expansion. Not a single beginning, but a rhythm of beginnings, separated by ages longer than any calendar can dream. Even the microwave background might carry the afterglow of such a meeting, a faint crease left in the sky's oldest fabric. Mathematics, being braver than habit, allows stranger turns. Some versions suggest the extra dimensions are the ones doing the expanding, while ours remain comparatively steady. To beings like us, bound to the big open directions, the effect would still look like growth. Imagine a balloon whose skin seems unchanged while its interior swells. Living on the skin, you would call it expansion, even if most of the change happens inward. Other sketches let some dimensions swell while others slowly contract, the total volume balancing like a seesaw kept level by opposing motions. Reality's overall size could be constant while our three-dimensional slice opens like a hand. These are working ideas, pinned to the corkboard. Our tools barely touch them. We do try. The Large Hadron Collider and careful tabletop experiments that feel for faint deviations in gravity's pull, hunt for hints of extra dimensions, missing energy that might slip into the bulk, tiny departures from Newton's law at very small scales. So far, no clear footprints. That could mean there are no hidden corridors. It could also mean the corridors wind tighter than we guessed, beyond the reach of our current keys. Mathematics keeps pointing toward the necessity of extra dimensions in certain unifying stories. Reality keeps its counsel, the way a lake keeps its depth in shadow. If extra dimensions turn out to be real, the idea of expansion changes flavor. It becomes less like a fabric making more fabric and more like a sheet relaxing in a larger room. If they do not, we still have enough mystery close to home. A universe that expands from within, with no outside to grow into. A horizon woven of time rather than walls. A quiet, even pressure dark energy teaching distance to lengthen. The multiverse may exist or not. Brains may drift and collide, or remain stories we whisper while we wait for clearer notes. None of this uncertainty threatens the meaning of this breath. Let the philosophical worry soften. If there are infinite copies, does that make this moment less yours? A mountain appears countless times in reflections on a lake, but each ripple still holds a particular moon. Meaning isn't mined from rarity. It appears where attention rests. Your choice matters because you are the one choosing, with one heartbeat, in one room. The echoes are not obligations. They are distant choirs you cannot hear. So picture the night as a lake with lantern boats set one by one on its surface. On one boat, the anthropic whisper a reminder that we notice what allows noticing. On another, inflation's mathematics, steady under the oldest light. On a third, curled dimensions, perhaps a clean three-room house with no secret stairs. The boats drift, their reflections widen, and you don't need to chase them. You can watch the glow blur, and in the blurring, find rest. Whatever lies beyond our horizon, bubbles, brains, or simply more of the same, the near horizon is kind. Breathe in, as if lifting the edge of a quilt. Breathe out, as the quilt settles. The universe may hold countless ways to arrange itself. Tonight, it has arranged a chair, a quiet room, and time enough for the mind to unclench. Let the questions keep their gentle motion. Like boats sliding toward the center of the lake, the answers can arrive when they're ready, on the slow water of light. What if space curls back on itself so gently that the question, what is it expanding into, loses its bite? Picture a donut growing thicker at the waist. It gets larger, yet it doesn't grow into anything. It is just more donut. That sounds playful, even absurd, until you remember that the shape of space decides what expansion means. In a flat, boundless space, distances stretch with no destination. In a curved, closed space, expansion can be nothing more than a round shape, quietly widening, returning to itself with no outside to seek. Einstein's theory lets space take on three broad personalities. One is flat, like an endless sheet of paper. Parallel lines stay friendly and never meet. Triangles behave themselves. Their angles add to exactly 180 degrees. This is the geometry most people carry around in the mind, without thinking. Another is positively curved, like the skin of a sphere. Draw two parallel paths, and they will slowly drift together, meeting at last. Triangles here are generous. Their angles add to more than 180 degrees. Walk straight long enough on such a surface and you can circle back home without ever turning. The third is negatively curved, a saddle shape, lines that begin parallel lean away from each other. Triangles are stingier. Their angles add to less than 180 degrees. This space stretches forever, but it has a gentle, perpetual lean. Measurements so far say our universe is flat, or so very close to flat, that any bend hides beyond what our rulers can feel. But flat does not automatically mean infinite. Take that paper and roll it into a cylinder, or glue opposite edges to make a donut. Up close, the paper is still flat. Triangles still add to 180 degrees, yet the whole object becomes finite and self-wrapping. Space could be like that, locally flat, globally wrapped. If so, asking what it expands into becomes like asking where the donut puts its extra surface as it fattens. Nowhere. It simply becomes a larger version of itself. A wrapped universe would leave small traces. Light could circle the cosmos and return, giving us repeated images of the same faraway galaxy peeking from different directions. The oldest light, the cosmic microwave background, might show matching patterns, like wallpaper seams that line up around a room. Astronomers have looked hard for these repeating signatures, and so far, found none. That could mean space doesn't wrap on scales we can inspect, or it might be so large that light hasn't had a full lap yet. The donut, if it exists, may simply be too big for a single tour in the age of the universe. The shape story grows richer when you remember that space doesn't travel alone. It is stitched to time. Together they make space-time, a four-dimensional fabric. When the fabric stretches, it stretches both the where and the when. Early on, when everything was pressed close and hot, clocks would have kept a different rhythm than they do today. Even the idea of at the same moment across great gulfs loses its simple meaning. Expansion doesn't just lengthen distances, it also changes how time flows between those distances. This leads to a famous surprise. Faraway galaxies recede from us faster than light. That seems to break a cherished limit until you rephrase it properly. Nothing is racing through space faster than light. Instead, space itself is carrying things apart. It is the road unrolling, not the car speeding. From a distant galaxy's point of view, it is not dashing away. It sits still in its own neighborhood while the fabric stretches between us. Relativity keeps its promise. No local traveler outruns light. The stretching simply gives every observer the same honest view. Each sees themselves at the center of a smooth expansion, with everything else drifting away. There is no throne, no edge, no favored balcony seat. The universe expands by becoming more itself, not by pushing into and outside. Because space and time are woven together, stretching distances also stretches the rhythm of events we see. Imagine watching a supernova in a nearby galaxy. It rises to peak in a few weeks, then fades. Now watch the same kind of explosion in a very distant galaxy, one whose light has been stretched by expansion. The color is reddened, yes, but the timing is stretched too. The whole unfolding looks slowed down, as if someone gently pulled on the film. For a galaxy whose light is redshifted by a factor of 10, the clock we see there runs roughly 10 times slower than the clock here. The rule of thumb is simple. The time intervals we observe are multiplied by 1 plus redshift. It is not a trick. It is the fabric telling you how much it has relaxed during the journey of that light. This cosmic time dilation changes how the universe ages in our eyes. From here, the story reads 13.8 billion years. From a far-flung, rapidly receding perch, our region might look younger because the timestamps on our signals are stretched in the other direction. Age, in a universe like this, has local flavors. None of them are wrong. Each is honest to its own patch of fabric. The early cosmos didn't just hold more matter in less space. It held more happening in less time. Processes that now take eons, like gathering enough gas to light the first stars, could proceed more quickly back then, because clocks near that dense beginning ticked in a different rhythm, and because the entire environment was primed for change. Expansion also reshapes the idea of simultaneity. Day-to-day life trains us to think two events can be at the same time everywhere. Relativity and the growth of space nudge that comfort aside. When signals must cross an ever-lengthening distance, and when the road itself is stretching under them, at once, phrase. Two fireworks that are simultaneous for one observer may not be simultaneous for another, moving differently or sitting inside a region that has stretched more or less. The universe keeps truth, but it does not keep a single, universal clock. It keeps many honest clocks, each tied to its own path through space-time. Return for a moment to the gentle shapes. If space is truly flat and not wrapped, expansion is like a quilt whose squares slowly widen, with no border to meet. If space is closed, expansion is the donut thickening, surface area rising with no outside swallowed. If space is saddle-shaped, expansion still lengthens distances, but the grand geometry leans forever outward. In all three cases, the growth needs no container. The fabric is its own home. It helps to let the math turn back into pictures. Think of drawing a triangle on different worlds. On a sphere, you can walk straight from the equator to the North Pole, turn right, walk back to the equator, turn right again, and return to your start. You've made a triangle whose angles add to more than 180 degrees. On a saddle, the angles would add to less. On a flat plane, they tally to exactly 180. These are quiet, walking pace tests of curvature. Astronomers do the same in the sky with light from the early universe, using temperature patterns as their ruler. So far, the tally says flat enough, but the world could still be wrapped in ways the ruler cannot yet feel. There is a final, tender twist. If expansion stretches time as well as space, then the flow you feel second by second may be part of the same grand easing. The universe may not just be growing, it may be aging by the same weave, all of us carried on the slow tide of space-time. You don't need the equations to feel the shape of that thought. It is enough to picture distant lanterns drifting on a black lake, their light arriving redder and slower, their stories told in a longer syllable. It is enough to know that every observer, on every shore, sees the lake widen in the same calm way. No edges, no outside, no center throne, only a fabric that loosens a little with each cosmic breath, a clock that keeps many honest tempos, and a sky whose shape may be flat, closed, or quietly curved, but always complete from the inside. Let the mind hold that completeness the way a hand holds a smooth stone, not to measure it, only to feel its calm. Breathe in, and the distances soften. Breathe out, and the questions do too. Whatever the true shape of the world, it needs no room beyond itself to grow. It needs only time, which is growing along with it. and a listener willing to drift with the story until sleep folds the page. What feels simultaneous here may not line up with now in a far-off galaxy. There is no single universal clock that stamps the whole cosmos at once. Each place carries its own honest rhythm, and on the widest scales, right now is local. As expansion accelerates under dark energy's steady push, these differences grow. Distance stretches not only space, but the way we see time pass. Faraway events look slowed, as if the film were gently pulled. Push far enough and they seem almost frozen, like lanterns paused on a black lake. Follow that widening, and it points toward a cold horizon. If expansion keeps easing everything apart, gravity and chemistry will have less and less to work with. Over very long ages, star birth dwindles, and the bright cities of the sky go dark. The universe drifts toward heat death, a quiet state where matter and energy are so thinly spread that no useful temperature differences remain. No engines can run, no new structure can rise. It is not a crash, but a fade, a slow settling toward uniform night, near absolute zero. The timeline is enormous, more lullaby than countdown. Long after tonight, long after any measure that fits in a human story, stars will flicker out. Red dwarfs, the penny savers of the cosmos, burn so slowly that some will glow for trillions of years. Others will end far sooner. As the supply of cool gas thins, new stars form less often, then rarely, then almost never. The degenerate era begins, ruled by embers, white dwarfs, neutron stars, and quiet, dark remnants. Even matter itself may not keep faith forever. Many theories allow protons to be unstable on fantastically long timescales. If protons do decay, then after something like 34 years, and likely much longer, atoms would fall apart into lighter particles. The familiar furniture of matter would simplify into a thinner and thinner soup. Electrons, positrons, photons drifting through a vast, almost empty room. It's a number so large, the mind can only treat it like weather there, but too far to feel. Still later, black holes take center stage. They are not eternal. Through Hawking radiation, they slowly leak energy, turning mass into a faint trickle of particles. Small ones go first. Stellar mass holes take far longer than today's universe has lived. The supermassive giants at galaxy centers could last around 100 years. When the last one sighs away, the cosmos will have few notes left to play. No gradients, no chemistry, no computation. Entropy, the tendency toward disorder, will have done its quiet work. What remains is smooth and still. There's a nearer consequence, too, measured not in eternities but in long tomorrows. As the fabric keeps stretching, faraway galaxy clusters slip beyond our horizon. They aren't destroyed. Their light simply can't outpace the growth of space. From here, they dim, then vanish. In roughly 100 to 150 billion years, only the small island of galaxies bound to us, our local group, should remain visible. Future astronomers, limited to that shrunken view, might read a very different story. The sky would offer no obvious sign of expansion, just a handful of neighbors in a velvet dark. The ancient afterglow, the cosmic microwave background that now whispers the universe's warm childhood at 2.7 degrees above absolute zero, will redshift to wavelengths so long that no practical instrument can hear it. The best clues we have today would slip out of reach, and the past would hide behind time's expanding sea. Some theories even sketch a sharper end. If dark energy grows stronger than a steady cosmological constant, if it crosses into phantom behavior, the expansion could become a true rip. First, galaxy clusters would unbind. Later, galaxies themselves. Then star systems. Then planets. Then molecules. And finally, the very bonds inside atoms would be pried apart. Space wouldn't just empty, it would tear. Most evidence today points to a gentler fate, but the possibility sits on the shelf, a reminder that the universe keeps options tucked in its sleeves. All of this leans on a deeper truth. The vacuum is not empty. What looks like nothing is busy. At the smallest scales, fields never quite sit still. Pairs of particles and antiparticles flash into being and cancel again in less than an eye's blink of an eye's blink. You can think of the vacuum as a soft boil, quantum foam, foaming and smoothing so quickly that our senses see only calm. The more energy these short-lived pairs borrow, the faster they must repay it, in line with Heisenberg's uncertainty principle. It sounds like cheating, but it is how the rules are written at the bottom of things, and it leaves real fingerprints. Vacuum activity nudges atomic energy levels, bends light near strong fields, and on the grandest stage, behaves like a uniform pressure that pushes space apart. This is one way to picture dark energy, the baseline hum of the vacuum, distributed everywhere, encouraging the fabric to keep relaxing. Stretching space stretches time with it. That's why a distant supernova seems to take longer to rise and fade than a similar one nearby. Not only are its colors shifted red by the journey, the beats between its light pulses are stretched too. A common rule of thumb says the slow motion factor is 1 plus redshift. Look near the edge of the observable universe, and you're watching events unspool many times, slower than here. Add the relativity of simultaneity, the fact that different observers slice space-time into nows differently, and the idea of a single cosmic present melts away. Each place tells an honest story from its own clock, and no clock rules all the others. This can feel unsettling until you see its kindness. Without a universal now, there's no global scoreboard to chase. Meaning doesn't come from being first on a cosmic clock. It comes from being present on your local one. The expansion's long arc does not demand your worry. It barely notices our small century of light. The dark energy that lifts distances does so evenly, not in leaps. Heat death, if it is our fate, sits so far down the road that the word road fails. And even that end is more like a dimming lantern than a door slamming shut. Meanwhile, the present is generous. Galaxies still braid in clusters. Stars are born in cold clouds lit at the edges by newborn fire. On one small rocky world warmed by an ordinary star, a mind listens to a story about time that lengthens as it goes. If distant events look slowed, let them be. If tomorrow's sky grows lonelier, it will do so on timescales that ask nothing of your sleep. You can hold the whole picture lightly. No universal now, only local moments. A future where expansion thins the night, a possible rip, more likely, a long, cool hush. A vacuum that isn't empty, teaching space how to ease. Clocks that keep honest tempos in their own neighborhoods. Breathe with that. In, a calm tide. Out, the shore a little wider. The universe doesn't need an outside to grow into, and you don't need every answer before rest. Let the lanterns on the far lake drift in slow motion. Closer in, let the room settle, the breath lengthen, and the page grow warm in your hands. Let's slip a little deeper into the quiet and peek at empty space, which is anything but. According to quantum field theory, the vacuum hosts every kind of virtual particle that the laws allow. Pairs flicker into being and vanish again so quickly that our instruments catch only their footprints. One of those footprints is something you can measure in the lab. The Casimir effect. Place two uncharged metal plates a hair's breadth apart in vacuum. Waves with wavelengths larger than that gap can't fit between them, but they can still exist outside. Fewer modes inside, more outside. The imbalance presses the plates together with a tiny, real force. It is, in a sense, the touch of the quantum vacuum. This foam should contribute energy to space itself. Do the naive calculation, though, and you get a cosmic embarrassment. The vacuum should carry about 10, 100, and 20 times more energy than the dark energy we actually infer from the sky. If that were true, the universe would balloon at a rate that would rip the story right out of our hands. Something in our reasoning must be off. Either the way we tally vacuum energy is misguided, or there is a deep cancellation that trims the sum down to the gentle value we observe. One possibility: most of the vacuum's wild energy cancels out, leaving a small residue that behaves as dark energy, the even pressure behind the universe's accelerating stretch. Another: hidden fields soften the foam. Extra dimensions let energy leak away. Emptiness is an illusion stitched by our limited view. Some ideas go further and treat space as made of parts. Loop quantum gravity imagines space-time as a lattice of tiny, discrete units, atoms of volume linked like a crystal. String theory imagines space as emergent from vibrating strings and their higher dimensional cousins, with geometry arising from their relationships. In both stories, nothing is a structure with inner life. If space has components, expansion may be the gentle rearrangement of that structure, the stretching of something rather than the creation of nothing. The universe needn't expand into an outside. It may be expanding within the fabric it already is. The mind can hold that and still ask about a louder possibility. What if the stretch keeps strengthening, outrunning every force that holds reality together? One speculative path is the Big Rip. In this tale, dark energy doesn't remain constant. It grows more intense, its equation of state dipping below the calm value we measure today. The timeline, if those conditions hold, is a sequence that feels like a countdown set to a distant clock. About 1 billion years before the end, gravity would lose its grip on clusters. The great cities of galaxies would drift apart, unable to hold one another. 200 million years before the finish, individual galaxies would dissolve, their stars cast loose into an enlarging night. About 30 minutes before the final moment, solar systems would unbind planets, pulled from their stars, moons from their planets. 90 seconds on the clock, and molecules would part company. Atmospheres would unravel, not from heat, but because the space between molecules grows faster than their bonds can pull together. A trillionth of a second before the end, even nuclei would fail. The strong force would be outpaced by the accelerating metric, and protons and neutrons would fall to pieces. At the last instant, the very rules for measuring distance and time, the metric itself could break down. When the fabric is stretched past a limit, fabric may not be the right word anymore. That is one ending, but it rests on a very specific behavior. Dark energy must strengthen over time. If dark energy remains constant, more like a cosmological constant than a restless field, the Big Rip never arrives. The universe coasts toward the long, cool hush of heat death instead. Our best measurements so far suggest the calm option. The data are consistent with a constant dark energy. those small drifts haven't been completely ruled out. Future observations, more supernovae as standard candles, better maps of the cosmic web, sharper traces of expansion will tighten the story. If there is any strengthening, we can estimate the date of the rupture. Conservative sketches point to 22 billion years from now. Bolder ones pull the horizon closer. Either way, these are ages beyond any worry fit for a bedside. And even the harsh ending hides a strange solace. Some models imagine the rip seeding fresh inflations, new bubbles blooming from the torn thread's beginnings, smuggled inside an ending. While those possibilities float like far lanterns, our feet stay on the boardwalk of evidence. We learned the universe is stretching not by clever philosophy, but by patient light gathering. The trick was to turn the deaths of certain stars into rulers. Type Aya supernovae. Those steady lighthouses flash with nearly the same true brightness. Compare how bright they look to how bright they should be, and you get distance. Compare distance to how much their light has been stretched redward, and you get the rate at which space grew during the light's journey. Plot many such beacons across the deep, and the curve tells you a secret. The expansion hasn't just continued, it has quickened. That's the large canvas. Back at the small scale, return once more to the vacuum's whisper. Virtual pairs flicker so quickly that the more energy they borrow, the shorter the time they're allowed to live. Heisenberg's promise that precision in energy and time can't both be perfect. Electron-positron pairs can haunt the vacuum for to 10⁻21 seconds. Heavier pairs for even shorter. This boil leaves tiny, testable scuffs the Casimir squeeze between plates, slight shifts in atomic energy levels, subtle bending of light near strong fields. Across the cosmos, it may also add up to the smooth pressure we have named dark energy. The number is small enough to be gentle and large enough to be destiny. Between the near hush of heat death and the sharp tear of a rip, the present keeps its own quiet duties. Expansion stretches time as it stretches space. Distant fireworks unfold in slow motion. Now remains a local word, and the universe needs no outside to grow into. If endings must be imagined, let them be imagined lightly, as whether too far to influence tonight's sleep. What we can do, and what astronomers have done, is keep listening to reliable candles and the oldest glow, keep weighing the universe against itself, and keep smoothing the picture until the seams show or vanish. For tonight, let the paradoxes turn soft at the edges. Empty space isn't empty. The vacuum hums. The numbers are enormous but not urgent. Somewhere, two metal plates feel the faint push of nothing. Somewhere else, a supernova lights the yardstick again. And here, breath widens and settles, keeping tempo with a cosmos that expands by being more itself, one unhurried beat at a time. Settle a little deeper and let the stars do the counting for you. Some of them end in a way that is wonderfully predictable. A white dwarf, an ember of a star, siphons matter from a companion until it crosses a sharp threshold and detonates. That detonation, a Type Ia supernova, shines with nearly the same true brightness wherever it happens. Because its wattage is known, its apparent dimness becomes a ruler. Measure how faint it looks, compare it to how bright it should be, and the distance falls out like a quiet answer. While the light is in your hands, you also read its color shift. Starlight stretching through a growing universe arrives redder than it left. That redshift tells you how much the fabric expanded during the journey. Higher redshift means the light crossed more, stretching farther away, earlier in time. Put the two together, distance from brightness, redshift from color, and you can pin a point on the universe's growth chart. Do it not once, but hundreds of times across the sky, and a pattern appears. If expansion had coasted at a steady rate, the points would line up straight. If gravity had been winning, pulling things back, distant supernovae would sit nearer than you'd expect. Instead, they are fainter, farther evidence that the fabric expanded more while their light was en route. The curve bends the other way. Acceleration. Supernovae are not lone heroes. They stand on a ladder carefully built from nearer rungs. At the bottom is parallax, the simple geometry of a planet in motion. As Earth loops the sun, nearby stars shift slightly against the far backdrop, a tiny wobble you can measure. With that angle and the size of Earth's orbit, you get precise distances to stars within a few hundred light years. Those well-measured stars calibrate the next rung, Cepheid variables. These stars breathe brightening and dimming with periods that tie directly to their true brightness. Time the pulse, learn the wattage, and the dimness gives the distance. Cepheids carry you from our neighborhood out to other galaxies tens of millions of light years away. From there, Type Ia supernovae take the baton, reaching across billions of light years. Each rung relies on the one below. The whole ladder stands only as straight as its joints are honest. This reliance is why a small mismatch has become such a loud whisper. When astronomers climb the local ladder parallax to Cepheids to supernovae, they infer an expansion rate around 73 kilometers per second per megaparsec. When they read the rate from the baby picture of the universe, the cosmic microwave background, and evolve that picture forward with our best physics, they land nearer 67. 6% doesn't sound like much until you ask the cosmos to be precise. Either some subtle bias hides in one of our methods, or our big picture model needs a new stitch. The tension doesn't undo what matters most. Both routes agree the universe is expanding, and supernovae show that expansion is accelerating. The disagreement is a teacher, not a threat. Breathe once, and we'll slip the math into soft focus. Cosmologists use a single, patient function to describe how distances change with time. The scale factor, written as at by convention. Today is a equals 1. Earlier times are a is less than 1. Later times are a is greater than 1. When a doubles, every large-scale distance doubles with it. Redshift knits neatly to a. Observe a galaxy at redshift z, and you're seeing it when the universe's scale was a equals 1 divided by 1 plus z. A galaxy at z equals 1 lived in a universe half its current size. The oldest afterglow, the microwave background, comes from z, approx 1090, when R was roughly 1,000th of today, and space's volume was about 1 billion times smaller. A single number, rising with time, carries the story. Fold in Einstein's field equations, and the scale factor becomes a forecast. If art grows linearly, the universe coasts. If it bends upward, faster than linear expansion accelerates. If it bends downward, gravity is winning and the growth slows. For about 5 billion years now, the curve has been bowing upward. That tells us the even pressure we call dark energy has taken the lead. Keep the pressure truly constant, and the future is a slow exponential. Distances grow more quickly, but the acceleration itself settles to a steady hum, and the cosmos drifts toward heat death as matter thins. Let the pressure strengthen with time, and the curve steepens into a big rip, the dramatic ending where expansion eventually pulls apart everything that binds. Let it weaken, even turn negative, and the growth could halt and reverse, ending in a big crunch. Current measurements favor the calm first path. The scale factor does one more kindness. It links the tempo of growth to what fills the universe. More energy density means stronger gravity in Einstein's language, and, paradoxically, a faster initial expansion when the universe is young and jam-packed. Early on, radiation and matter crowded the stage, and ET grew quickly but decelerated as the crowd spread out. About 5 billion years ago, the balance tipped. Dark energy's density stays effectively constant, even as space expands. Matter's density dilutes. The even pressure took over, and ET began to bow upward. Fit the curve to the data, and you read the budget. Today's cosmos is roughly 68% dark energy, 27% dark matter, and 5% ordinary matter, the bright fraction that makes stars, seas, and sleepers. As time goes on, the constant density of dark energy ensures its share of influence only grows. Distances will keep learning to lengthen. All of this ladder's built on starlight, a scale factor that turns redshifts into times and distances rests. Curiously, on a lesson learned from a famous misstep. A century ago, a great mind tried to keep the universe still by adding a term to the equations, a gentle pressure meant to balance gravity. Later, he called it his biggest blunder. The night has a sense of humor. That quiet term looks very much like what we now observe. The fabric does not need an outside to grow into. It needs only this soft pressure to ease its threads apart. Let the numbers dim again and the images take over. A white dwarf reaches its limit and flashes a perfect candle. Its dimness measures distance. Its reddening counts the stretch of time. Stars that breathe give us the rungs to climb. The afterglow from the universe's warm childhood sets the baseline. The scale factor raises and falls in a smooth arc we can trace with patient light. The future sits folded inside that curve, not demanding worry, just inviting understanding. Tonight, it's enough to know the map exists, and the path is gentle. The universe keeps time, with many honest clocks, and yours is one of them. Steady, local, and exactly right for this quiet room. Settle back and imagine a mind so sharp it could bend starlight with a pencil and still make a beautiful mistake. Albert Einstein finished his new theory of gravity in 1915, and 2 years later faced an awkward truth it contained. His equations wouldn't allow a perfectly still cosmos. The math said space must either swell or shrink, yet the telescopes of the day seemed to show a calm, eternal sky. Trusting the evidence he had, Einstein added a small extra term, lambda, the cosmological constant, a gentle outward push to balance gravity's inward pull. Space, he suggested, carries a faint energy of its own, a built-in repulsion that could hold the universe steady like a coin perfectly balanced on its edge. For a while, that picture felt tidy. Then Edwin Hubble climbed the mountain at night and measured what the sky was truly doing. He found galaxies beyond the Milky Way, whole island cities of stars, and he measured their distances using pulsating yardstick stars called Cepheids. When he compared distance to how much their light was stretched redward, a pattern appeared. Everything far away was receding, and the farther it was, the faster it pulled away. Not debris racing through still space, but a fabric in motion. The universe was expanding, after all, just as Einstein's unedited equations had whispered from the start. Einstein set lambda aside and later called it his greatest blunder. Time, with its quiet sense of humor, circled back. In 1998, two teams reading the light of Type Ia supernovae discovered that expansion isn't merely continuing, it's speeding up. Something smooth and uniform is pushing space apart, gently but relentlessly. That something behaves exactly like Einstein's lambda, a constant energy woven through empty space, a pressure that never thins as space widens. The value is tiny, on the order of a billionth of a joule in every cubic meter, yet multiplied by the vastness of the cosmos, it outweighs all stars, dust, and glowing gas. The term once added to keep the universe still now explains why it accelerates. The alleged blunder begins to look like foresight. There's a riddle tucked inside this comfort. If the vacuum truly carries energy, why is its value so small? Quantum field theory, when asked to tally the vacuum's energy, hands back a number preposterously larger than what the sky allows off, by about 10^120. It's as if we balanced a feather by canceling the weight of a mountain to within a single snowflake. Either the calculation misses a deep cancellation, or our understanding of nothing needs a new grammar. Some models soften lambda into a field that can change with time. Others hint that hidden symmetries subtract almost everything, leaving just the whisper we observe. For now, the simple, steady cosmological constant fits the data best, and the vacuum's small, stubborn hum goes on guiding the future. Hubble's story deserves its own quiet telling. Before his measurements, astronomers argued over the spiral nebulae, misty swirls in the sky. Were they small clouds within our galaxy, or great galaxies of their own, far beyond? Using Cepheid variables, stars whose pulse period reveals their true brightness, Hubble proved those swirls were distant galaxies, millions of light years away. The known universe jumped from one city to a continent of cities. When he plotted distance against redshift, he found a simple line: twice as far, twice as fast, 3 times as far, 3 times as fast. This is now called Hubble's law. At first, even Hubble pictured galaxies racing through a static arena, like shrapnel from a single explosion. That would have placed us at the center, a special seat the cosmos rarely grants. The better view is quieter and kinder. Space itself is expanding. Paint dots on a balloon and inflate it. Each dot sees every other dot drift away in proportion to their separation. No dot is the center. The center is everywhere. Galaxies ride along like raisins in a rising loaf. Motion through space is not the story. Motion of space is. Hubble's earliest distances were off. He mixed up types of variable stars, and his first version of the expansion rate was too high, which made the universe absurdly young. Astronomers corrected the yardsticks, and the ages settled into harmony. Earth older than 4 billion years, the universe older still. What never changed was the core pattern. From the nearest galaxies to the edge of sight, distance, and redshift keep their quiet proportion. Expansion is a global habit of the fabric, not a local breeze. That pattern became the foundation of Big Bang cosmology, a universe that began hot and dense, then cooled and spread, carving time enough for stars to learn their steady fires, and for life to wonder at them. It also raised the larger question of fate. If expansion is a habit, what sets its tempo? Lambda offers the cleanest answer we have: an even pressure in the vacuum that doesn't dilute as space grows, so its influence increases as matter thins. In the math, this appears tenderly inside the scale factor, a simple function that tracks how big the universe is relative to now. For about 5 billion years, that function has been curving upward, telling us acceleration is not a rumor, but the current weather of the cosmos. All this theory, revised by humility, observation corrected by patience, shows how science moves like breath. In with an idea, out with a test, in again with a better fit. Einstein added lambda to freeze the sky, then tossed it when the sky said otherwise. Decades later, the sky asked for lambda back. His extra term, meant to cancel motion, became the clearest way to describe the motion we see. There's poetry in that turn, and also a lesson. Even the finest minds lean on the light that arrives. Hubble, too, changed what seeing meant. Before him, astronomy was mostly a flat map of positions. After him, the universe gained depth and tempo. Cepheids and supernovae became yardsticks. Redshift became a clock. The expansion rate became something we could write down and argue about. We still argue, gently but seriously, over its exact value, whether local ladders point to a faster pace than the baby picture of the cosmos implies. That small tension may be an accounting error waiting to be found, or the first hint of new physics. Either way, both routes agree on the melody. The universe is growing, and the tempo is quickening. Let that melody drift into metaphor. Lambda is a soft hand on the quilt's edge, pulling with the same light touch everywhere. Hubble's law is the spacing of the stitches, widening with distance. The balloon isn't bursting, it's simply inflating. The loaf isn't tearing, it's rising. No outside is needed. The fabric becomes more itself. And beneath it all, the vacuum hums a tiny, tireless tune that adds up to destiny when played across an ocean of space. If you listen closely, the story carries a human kindness. Einstein's blunder wasn't a failure so much as a step in a longer walk, the kind we all take. Revise, learn, return, refine. Hubble's line on a graph was a new way to breathe the night, a way to turn brightness and color into distance and time. Together, they gave us a picture of a living cosmos, one that began, one that changes, one that will go on changing long after our small lamps are dim. Let that picture be gentle. The numbers can wait on the shelf. The lesson can rest on your chest like a warm stone. The universe expands by becoming more itself, and our job is simply to notice, with patience and a steady breath. Let the question rest in your hands like a smooth stone. Does the widening go on forever, or will gravity one day gather everything home? The answer lives in a delicate tug of war between the outward ease of expansion and the inward pull of mass. There is, tucked into the math, a precise threshold. Call it the critical density where the two balance. Astonishingly, that threshold is small. On average, about 5 hydrogen atoms in each cubic meter of space. Almost nothing, and yet enough to tip the fate of everything. Imagine 3 futures written on a hillside. If the cosmos holds more than this threshold, gravity wins. The climb slows, stops, and turns back. The rise becomes a fall. The story curls into a big crunch. If it holds less, expansion keeps its lead. The hill levels into a long, cool plain, and matter thins toward heat death. Right on the line, the universe coasts forever, slowing without stopping. Like a ball tossed upward with exactly the escape speed, never falling back, never quite coming to rest. For decades, we tried the obvious, count the stuff, but most of the mass refused to shine. Stars at the edges of spiral galaxies orbit too fast to be held by visible matter alone. Their speed betrays extra gravity, about 5 times more than starlight can explain. We named that hidden weight dark matter not because it is sinister, but because it neither glows nor absorbs, only tugs. When we add it to the ledger, the universe comes out close to 1/3 of the critical density. That looks like a forever expanding story. Then the night whispered a new term: dark energy. It does not clump, it does not thin as space grows. It behaves like a uniform pressure spread everywhere. And in Einstein's equations, a smooth energy with negative pressure gently speeds expansion up. With dark energy in the budget, the simple "how much stuff" question changes flavor. It isn't only the amount of energy that matters, but how that energy pushes or pulls. Today's best fit is a quiet partition, roughly 5% ordinary matter, 27% dark matter, and 68% dark energy. In that mix, and with the repulsive effect of dark energy, accounted for, the geometry looks exquisitely close to flat. From our vantage, the universe balances on a knife's edge. Balance invites a second question: why so close? In most early universe models, even a tiny mismatch from critical density would have blown up, with time curvature racing away into a universe that either collapses too soon or empties too quickly. Keeping the cosmos near flatness would seem to require an almost supernatural fine-tuning at the beginning. The gentlest answer we know is inflation, a brief, furious stretching in the first instant that irons any initial curvature almost perfectly flat. After such a smoothing, the fabric emerges already near the balance point. Continued evolution nudges, but does not overturn it. Even then, a coincidence remains. We happen to live during the brief Middle Era, when all the big components, ordinary matter, and dark energy, carry comparable weight in the cosmic story. Not long ago, matter dominated. Not long from now, the even pressure of dark energy will rule almost entirely. Why now, of all times? One soft reply is selection. Stable stars, heavy elements, and time for chemistry tend to favor epochs when matter is neither too thick and violent, nor too thin and tired. Observers will naturally find themselves in neighborhoods and centuries where observation is possible. It isn't destiny so much as a filter. We notice the conditions that allow noticing. Let the thought widen a little farther, like a shoreline at low tide. Perhaps our universe is not the only stage. In the picture called eternal inflation, the rapid early stretching does not end everywhere at once. It halts in pockets, bubbles, each cooling into its own universe with its own settings. Elsewhere, the stretch goes on, spawning more bubbles without end. Our observable cosmos would then be one small lantern in a field of lanterns, each with its own pace of expansion, its own mix of matter and energy, its own curve of fate. Some pockets might brim with matter and slow quickly. Some might be thin and rush toward emptiness. A few might collapse in a blink, others relax for trillions of years. The multiverse, if it exists, is not a single road, but many footpaths through the same dark wood. There are even bolder whispers. Some physicists read quantum mechanics to mean that every allowed outcome of a measurement plays out, each in its own branch, a many worlds chorus of histories. On that view, reality is always fanning out, and expansion is a background rhythm shared by countless versions. Whether or not these branches or bubbles can ever touch us, they change the tone of the question, why here? Why now? From accusation to acceptance. In a garden with many seeds, some flowers will naturally bloom where bloom is possible. Return to the knife's edge. Critical density is not a brittle line scratched on stone. It is a balance traced in the scale factor, the quiet function that tells how distances grow. In the young cosmos, matter and light packed the room. Gravity's pull made the curve bend downward even as the room grew. As space expanded and matter thinned, the even hush of dark energy stayed constant. And about 5 billion years ago, the curve bent upward. That inflection deceleration giving way to acceleration marks the transition from the age of structure building to the age of gentle widening. In the far future, the percentages shift further. Matter dilutes, dark energy keeps its steady density, and the scale factor approaches an exponential rise. The knife's edge becomes a long glide. Numbers can sit softly if you let them. 5 atoms in a cubic meter, on average. 5% luminous matter, 27% dark scaffolding, 68% quiet pressure. Enough to make a universe level and long. Enough to keep galaxies apart kindly without tearing them now. Each figure is a bead on a string you don't have to pull tight to admire. It helps to keep the pictures near, for flatness, a vast quilt that, from any patch, looks straight-stitched. For critical density, a ball tossed at exactly escape speed, rising forever, slowing, never falling back. For the cosmic budget, a recipe where the spice you can't taste by itself. Dark energy sets the whole dish's character. For the multiverse, lanterns across a foggy field, each with its own warm circle of light, most hidden from one another, all flickering to their own tempo. And for tonight, the simplest map of all, your room, your breath. The thought that we live at a moment when the universe is balanced enough for stars to be old and worlds to be steady, for questions to sit without urgency, for sleep to arrive without the need to solve the sky. Expansion may continue. Gravity may never call us home. Other universes may or may not bloom beyond our reach. None of that presses on this minute. Let the knife's edge be a line of moonlight on still water, precise, quiet, and easy to watch until the lids grow heavy. Settle into the idea the way you'd settle into a worn chair. The cosmos may not be a single story, but a library. In one wing, universes branch like quiet river deltas, endless, subtle forkings of quantum possibility. Most branches hum the same melody, with only a few notes swapped. Others wander into new keys. In some, dark energy leans a little harder and distances widen more quickly. In others, gravity holds the reins longer and the great drift slows. Every admissible expansion, fast or slow, finds a stage somewhere in that quantum choir. It's easy to feel unmoored by this. If there are parallel versions of you riding out every fate, some under gentle heat death, some near a rip, some in a universe that will curl back into itself, what weight does this single path carry? The answer can be soft and local. Meaning isn't auctioned to the highest infinity. It is made where you are. Even if there are other books in the library, this page is still yours to read. The notion of many universes also nudges the word expansion into new shapes. In a single cosmos, expansion is the growth of all space. In a multiverse, our expansion may be just one layer of a larger weave, our three-dimensional room, easing outward, while the greater house remains unchanged. Or perhaps the house itself is growing in ways we can't name. People have peered into the oldest light, the cosmic microwave background, searching for faint rings or bruises that might betray a distant brush with another bubble. So far, the sky has kept its secrets, but the absence of fingerprints isn't proof that no other hands exist. The scales are vast, the traces delicate. Some questions may be companions rather than conquests. Even without neighbors, our own universe sets puzzles about what expansion does to information, knowledge, memory, identity, the patterns that briefly make a life. Physics carries a stubborn rule. Information is not destroyed, yet the fabric keeps loosening, and what was once near becomes far. Every thought you've had is a pattern in matter and energy. Molecules arranged to hold a memory, atoms lined up to make a signal, charges moving in step. As distances stretch over unimaginable time, those arrangements spread, thin, and lose their coherence. On such scales, the specific pattern that is you could drift apart beyond any hope of reconstruction. The holographic principle offers a counter-melody. Perhaps the information in any region can be encoded on its boundary, the way a hologram holds a three-dimensional image on a two-dimensional plate. As space grows, the area of those cosmic boundaries grows too. The universe's capacity to store information increases. Complexity has room to rise, even while existing patterns become more dilute. There is a strange tenderness in that. A cosmos that makes space for more stories, even as earlier chapters fade. Quantum mechanics adds another layer of quiet resilience. Some information rides not in exact locations, but in relationships, correlations that can span great distances. Entanglement ties particles together so that their states stay linked, no matter how far they drift, without sending messages or breaking light's speed limit. In that sense, expansion can carry entangled partners to opposite horizons, and the connection still hums in the mathematics. Patterns written in correlations may persist, even as the matter that once carried them grows far apart. But expansion also builds horizons, boundaries of causal contact. Regions that can chat today eventually slip beyond each other's reach, as space grows between them faster than light can cross. No signal can bridge the widening gap. Each region becomes an island of communication, holding a finite ledger of what can be known and shared inside. Information isn't destroyed so much as sequestered. The universe becomes an archipelago of memories, each bay lit by its own lanterns, no longer able to hail the others. On the largest scales, the cosmos keeps its own archive. The expansion history is written into the sky itself, the faint afterglow from when the universe first turned transparent, the large-scale distribution of galaxies, the gentle curvature of space-time. These are global patterns, a kind of cosmic diary. They persist even as local details smear out. Yet acceleration carries its own eraser. As dark energy continues to ease distances wider, the oldest light will slide to wavelengths so long that no practical instrument could hear it. The great clues will dim below any threshold. Far future astronomers, confined to one island of stars, might infer a small, static universe without beginning or drift. The record we read tonight could be beyond their reach. What should we do with that thought? Perhaps treat it like weather on a far horizon. Meaning doesn't require eternity. It prefers attention. The value of a song isn't cancelled because other songs are being sung, nor because the echo will one day fade. A life can be justified by its living. A civilization can be worthwhile for its making, its kindnesses, its curiosity, even if the larger room will one day grow so wide that its memories become local myths. If the multiverse exists, your story is still yours. If horizons multiply, the light on this shore is still light. If the record of the beginning will one day be too faint to read, tonight it is legible, and we can let it guide our questions with a calm hand. And if information is partitioned into islands, know that islands are enough for meaning. The tide between them doesn't need to be crossed for a lantern to glow. Let the metaphors do the lifting. Think of parallel universes as lanterns spaced across a foggy field most unseen, some guessed at, none needed for this lantern to warm your hands. Think of the holographic principle as writing on the inside of a shell, where the whole curve remembers what it contains. Think of entanglement as a shared rhythm between distant bells, no message sent, yet a pattern linking their chimes. Think of causal horizons as the line where sea meets sky, beautiful, unreachable, moving with the day. And think of time as a long exhale. As the fabric relaxes, it makes room for more patterns to briefly find their shape. Stars, rivers, conversations, the gentle conspiracy of neurons that knows the sound of its own name. Those patterns do not need to last forever to matter. They need only be true while they are. The universe may push outward without end. You may close your eyes and rest inside that widening, held by a present that is precise and local. Let the library be vast. Let most of its shelves remain unread. Let the page in your hands be enough. Breathe in steady, even. Breathe out the shore a little farther. Somewhere, patient instruments are still listening for bruises in the oldest light. Somewhere, the math is still arguing with itself about vacuum and value. Here, a chair, a room, a listener. The cosmos expands by becoming more itself. You do not have to solve it to sleep beside it. Picture a night sky 150 billion years from now. An astronomer stands where you stand, shoulders loose, breath slow, and sees a universe that looks nothing like this one. The horizon has pulled away. The great cities of galaxies have slipped beyond sight. What remains is a small archipelago. The Milky Way and Andromeda, long since folded into each other, their satellites gathered in, all of it blended into one wide, quiet oval of starlight, sailing alone through dark water. To those future eyes, that island will look like the whole of everything, the soft afterglow that once told us the universe was young. The cosmic microwave background will be stretched so far into cold, long waves that no instrument can catch it. The neat line between distance and redshift that taught us expansion will be unmeasurable, because there will be no distant beacons left to map. The evidence that led us from guesswork to a story will have thinned into silence. Their science will still be careful and bright. Their conclusions will simply fit the sky they can see. A quiet, timeless cosmos, a lone galaxy at ease in an endless, empty room. The past will hide in elder stars, tiny traces of the first elements inside ancient light, but the loudest clues will be gone. Those future minds will face what philosophy calls an epistemic fog. The method works, the data are true, and the world it describes is wrong, because the horizon has taken the witnesses away. That thought leans back toward us. Are we, too, children of our moment, missing evidence that earlier centuries could read or later centuries will never find? Somewhere just after the first light, perhaps other watchers could see things we can only infer. Somewhere far ahead, watchers may find only a gentle dark and a handful of embers. Follow the timeline forward, and even embers run out. Star-making slows when the gas thins. The long-lived stars burn on, then dim. Planets cool. In ages so large they feel like weather. Black holes whisper themselves away as radiation. What's left is a thin mist of the simplest particles, drift on drift, and a temperature so close to zero that numbers lose their pulse. It is not destruction by fire, but by diffusion, a long exhale until no breath remains to stir a flame. Someone might still be there to notice in some pocket, for a while, looking out at a sky with no structure at all. From there, the story would seem simple. A few particles, an endless void, no origins to speak of. They would have no way to imagine that their world once glittered with trillions of galaxies. The universe would be true to them, and yet the deeper truth would have gone to ground. It is tempting to ask for consolation, to seek a final reveal that rescues meaning from the wideness. The better comfort is quieter. The stage that made everything possible was expansion itself. The swell of space gave gravity time to gather, time for clouds to cool, time for stars to learn their steady fires, time for heavy elements to be forged in stellar hearts and thrown into new hands. Without the widening, there would be no rise and fall, no chemistry, no shores to name. The drama needs the stage to keep stretching, which returns us to the question that brought us here, turning it like a smooth stone until its edges wear gentle. What is the universe expanding into? The habit of daily life sneaks a container into the thought. Our minds reach for a room to grow into, a bowl to fill. But the universe is not inside anything. The universe is the thing that makes inside have meaning. Asking what it expands into is like asking what lies north of the North Pole, or which box holds the box that holds everything. The words fail because they arrive too early. There is no outside, because outside is a concept the universe writes as it goes. Expansion doesn't push into a pre-existing emptiness. Expansion is the making of room. As space grows, it creates the very relations near and far, here and there, that let distances exist. It is not a balloon swelling inside a larger air. It is the skin of the balloon writing the notion of air as it stretches. The map doesn't need a margin. The map is what defines where the margin would be. The universe expands by becoming more universe. Once you see it that way, the whole story softens. Expansion is not merely a mechanical process that makes the numbers climb. It is reality bootstrapping itself, space and time unfolding new possibilities with each breath. Every fresh cubic inch of room is a place where matter can arrange itself into star and rock and hand. Every easing of distance gives patterns a chance to emerge, to try themselves, to add a verse. There is no final destination where the widening must arrive to justify the trip. The journey is the point. Complexity flowers for a while and goes to seed. The seeds blow on the wind. The wind is expansion, and you are not standing outside this to watch it happen. You are made of it. The questioner and the question are the same cloth. A brain is space and time and matter, arranged exquisitely enough to notice that space and time and matter are arranging. When you wonder where the universe is going, that wondering is the universe becoming aware that it is going. When you ask what it expands into, the asking is part of the expansion information written on the moving fabric, a pattern that could not exist without the widening that carried it into being. Perhaps that is the deepest shape of things, a self-making process that doesn't need an outside or an end. No final ledger to balance, no purpose beyond the magnificent fact of becoming. If there are other rooms, other bubbles, other branches, let them be many. If the future hides its own record, let the present carry what it can. The truth is large enough to be temporary in places and still be true. Hold one last picture before the lights dim. The universe does not expand into a container. It expands into possibility, into mystery and wonder, and the endless capacity for more questions. It expands into the moment where a mind settles, a shoulder lowers, a breath lengthens, and a thought arrives clear as moonlight. We are part of this widening. We are the way the fabric knows itself for a time. We are not passengers on a vehicle headed elsewhere. We are the road, unrolling. Let that be enough. The porch is quiet. The tide of the cosmos moves without hurry. The map stretches a little farther while you rest. If there must be a final word, let it be a gentle one. The universe expands into itself, making room for everything it will ever hold, including this soft human amazement that it holds anything at all. Close your eyes. The story will go on while you sleep. Let the room grow softer until the edges blur. The last light folds itself small, like a warm ember, and the sky beyond the window drifts star threads gliding on a slow tide. You don't have to hold the map anymore. The road can unroll without your hands. The universe will keep making room for itself and for you while you rest. Feel the breath arrive like a quiet wave and leave like a darker hush. With each inhale, the world leans closer. With each exhale, it loosens and widens. Questions can set down their weight now. Nothing is closing, only dimming, like a theater after the final note, when the echo studies the rafters and then settles. Let your eyelids lower like a soft curtain. Muscles slacken, thoughts uncurl. If anything needs remembering, let it be this. You are cradled by a spacious, listening night. The stars will go on with their gentle work. The fabric will keep its patient widening. You can drift with it, breathe once more, and let the ember fade. The story doesn't end. It thins to a lullaby and slips ahead of you. Follow it, lightly, into sleep.